Hello students, good afternoon, welcome to 5 minutes physics. So in this lecture we will discuss and derive the expression of torque on a dipole which is placed in an uniform electric field. Then after we will discuss what is the variation of force on a dipole which is placed in a non-uniform electric field. So both part we will discuss in detail. So without wasting time, we'll start the video. My name is SRP and you are watching my beautiful channel Love You Saints. So we'll derive the expression of torque on a dipole in an uniform electric field. So for that, we'll consider a uniform electric field or we'll take a uniform electric field. This is uniform electric field. As you know, electric field, uniform electric field का मतलब क्या होता है? The lines of force should be parallel to each other and everywhere equal electric field. Everywhere you'll be getting same amount of electric field. Or you can say the strength of electric field intensity will be same everywhere. Clear? Next, we'll place the dipole or we keep a dipole here. As you know, dipole has two charges, minus q and plus q, and the separation between them is 2a. मैंने last class बोल दिया था. So we place a dipole or we keep a dipole inside the uniform electric field. And one more thing, the dipole makes an angle theta with respect to electric field. ठीक है? देखते हैं what is the net force. Tell me, you know, electric field का formula क्या होता है? Force upon charge. So what is force? Force is Q upon E. So since there are two charge here, we'll be getting two force. दो force मिलेगा. ठीक है? Since electric field will be same, both the charge will experience same force. So the positive charge will experience a force. The direction is what? Direction is along the direction of electric field, and minus Q will experience the same force. The magnitude will be same, but the direction will be opposite to the electric field. क्योंकि देखो इलेक्ट्रिक फील्ड का ये पॉजिटिव रीजन है, ये नेगेटिव रीजन है. नेगेटिव रीजन मतलब ये नेगेटिव रीजन इलेक्ट्रिक फील्ड का, ये हो गया आपका पॉजिटिव रीजन. So negative will attract that positive charge of dipole, and positive will attract the negative charge of dipole. So overall, what you will get? You will be getting two equal and opposite force. If there are two equal and opposite force, what is the net force? Net force will be 0. But net torque is not 0. Why? Because two equal and opposite force act at different arm. So we'll be getting a torque. So we can write here torque is not 0. Why it is not 0? I'm giving an example. Let this a marker. ये एक marker है. ठीक है? I'm applying 5 Newton force here and 5 Newton force. At the same time 5 Newton force here. So what is the net force? Net force is 0. But it will rotate. Why it will rotate? Because of torque. Torque is not 0. क्योंकि force is acted at different point or in two different arm. So torque is how much? Torque is not equal to 0. What is torque? Torque का symbol tau होता है. Torque का formula क्या होता है? Force, either force into perpendicular distance. कोई भी एक force ले जाओ into perpendicular distance. That is called torque. So force क्या है इधर? Force is QE. And what is perpendicular distance? This one is perpendicular distance, which is 2a sin theta. Why it is 2a sin theta? देखो ये राइट एंगल ट्रायंगल है, ये आपका 2a है, ठीक है, ये थीटा है, इसको p ले जाओ, इसको h ले जाओ. So p upon h is sin theta. So p will be h sin theta. So ये पार्ट कितना हो जाएगा? 2a sin theta. ठीक है? So मतलब ये 2a sin theta. q into 2a क्या है? p डाइपोल मोमेंट, q into 2a. ठीक है? So टॉर्क का इक्वेशन क्या मिल गया? pe sin theta. Now if theta is 0, then torque is how much? 0, because sin 0 is 0. If theta is 90 degree, torque will be maximum, which is pe. If theta is 180 degree, torque will be again 0. So vectorically we can also write tau is equal to p cross e. So to know the direction of torque, we can follow right hand thumb rule. What is right hand thumb rule? You know from vector product, if there are two vector product मतलब cross product. So p and e both are in one plane. Perpendicular to the plane will give the direction of torque. मतलब if p and e lies in xy plane, so you can get the direction of torque in z axis. एक एग्जांपल दे रहा हूँ, देखो ये प्लेन है, ये आपका x axis y axis है. So I am keeping p and e in xy plane and I will get torque on perpendicular to the plane, like on z axis. ठीक है? So right hand thumb rule, and torque will be maximum when tell me, when dipole moment is perpendicular to the electric field. Dipole moment मतलब dipole moment का डायरेक्शन क्या है? From negative to positive. If P is perpendicular to electric field, at that time we can get maximum torque. Is it clear? Okay. Now we'll talk about if a dipole is placed inside a non-uniform electric field. See, देखो, अगर if a dipole is placed inside a non-uniform electric field, the net force on the dipole will never ever zero. Since we have mentioned it is a non-uniform electric field, so the two charges of the dipole will experience different magnitude of force because field is different. Understood? So to understand this one, मतलब net force will never ever zero, right? So to understand this one, we can take an example. Case 1. Let us we have a electric field and the strength of electric field increases from left to right. Understood? And direction of electric field is also from left to right. See, there are two things. Direction of electric field is from left to right and strength also increases. मतलब यहाँ पे field strength जितना है यहाँ पे ज्यादा है, यहाँ पे और ज्यादा है, यहाँ पे और ज्यादा है. ठीक है? Then what we are doing? If I keep a dipole inside that electric field, and you know the direction of dipole moment is from negative to positive, so we can analyze this one. What I'm doing, I keep the dipole inside this non-uniform electric field and the direction of dipole moment is parallel to electric field. Then tell me what is the net force on the dipole. Since field is different, मतलब force will be different, क्योंकि यहाँ पे field कम है, यहाँ पे field ज़्यादा है, मतलब force on plus q charge will be more than force on minus q charge. That means net force is not equal to 0, and the direction of net force is along towards the electric field. See, the force due to that positive charge will be more than the force due to the negative charge. Since field is different, already मैंने mention कर दिया, the strength of field increases from left to right. मतलब यहाँ पे field का strength ज़्यादा है, यहाँ पे कम है, मतलब force on plus q will be more than force on minus q. So that means net force is not 0. So now the point is, what is the direction of net force? So obviously the direction of net force is along the direction of positive charge, or the force experienced on the positive charge. मतलब net force का direction क्या है? Along the direction of the electric field, मतलब increasing electric field. So that means we can write down the direction of net force act along the direction of electric field, or the direction of increasing in electric field, right? मतलब electric field का strength increase हो रहा है from left to right. Direction of force also act from left to right. So what you conclude from here, if dipole moment is parallel to the direction of electric field, or dipole moment if it is parallel to electric field, the net force act on the dipole will be on the same direction of increasing in electric field. Is it clear? So now we can take another case. Same electric field and strength is also increases from left to right since it is non-uniform, and the direction of electric field is also from left to right, we have assumed. And now if we keep a dipole in this way, like dipole moment ka direction dekho, it is opposite to the direction of electric field, then what will happen? See, obviously since field strength increases from left to right, so force on minus q will be more than force on plus q. That means net force is not 0. And what is the direction of net force? What is the direction of net force? From right to left. क्योंकि force on minus q will be more than force on plus q. So net force का direction क्या है? From right to left. So what you conclude from here? The direction of net force act along the direction of electric field, the direction of decreasing in electric field, the direction of decreasing in electric field, मतलब डिक्रीज इधर, अगर यहाँ ऐसे इंक्रीज हो रहा है मतलब इधर डिक्रीज हो रहा है. So that means the direction of force is act along the decreasing order of electric field, decreasing in electric field. It is clear? Okay. और एक चीज देखो, what about net torque? Can you tell me what is the net torque? Net torque will be zero. Why it is zero? Here also it will be zero. Why it is zero? Because force act along the line. Here also force act along the line. मे बी यहाँ पे फोर्स क्या है, डायरेक्शन क्या है, लेफ्ट टू राइट. यहाँ पे नेट फोर्स का डायरेक्शन राइट टू लेफ्ट, बट फोर्स एक्ट ऑन द लाइन which is passing through the axis of rotation. That means net torque will be zero in both the case. Okay, I think it is clear. So with this I am ending this lecture. Hope you guys understood. Thank you so much. Thank you.